So welcome back again. This is structural analysis made fun and easy. Sorry about that. I had a call where I was doing the video for the first part of this video. So I was just saying the waist of the staircase is 140 millimeters. The live loading on the stairs may be assumed as 2.5 kilonewtons per meter squared. The cover to all the steel may be assumed as 30 millimeters. Determine the factor load on the staircase. So first thing to do is just counting the stairs out. So we've got 1, 2, 3, 4, 5, 6, 7, 9, 10. So it's 10 risers, and then if you just draw the diagonal line parallel to the bottom of the soffit, then you've got 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 6, 7, 8, 9, 10. So that's 10 risers, so it's 10 steps. It says 140 waist. Well, it says here, you've got a span of 3 meters, but the arrows, it doesn't go to the edge of where the beam support is on each end. It's into the middle, so it's a bit imprecise, right? So just say 3 meters from there to the edge of this part, and then it rises by 1500. So let's get cracking on the part 1. Determine the factor loaded on the staircase. So first of all, it doesn't go back that well, but so we calculate the volume and therefore the weight of the steps. In addition, it says the factor loaded on the stairs, so you need the dead load and the live load, and the dead load is the weight of the waist plus the weight of the steps, and then the live load is just the 2.5 kilonewtons per meter squared times the safety factor. So it says calculate the volume and therefore the weight of the steps in addition to the weight volume of the waist, which is extremely straightforward. That's just so I've done it like this. Area of I'm going forward a bit, but it's just to show you. I've just tried to draw it isometric. This is a tread supposed to be a tread in 3D, and this is like the waist. So the waist is just a solid slab, just angled, and then the steps are on top of that. It doesn't say anything about formwork and stuff. I don't know what it might be in practice that it's, well, that's what it looks like. 260 tread, 150 riser, and this is not to scale, but so the area of one tread is obviously the area of a triangle. So let's go back to looking at it in elevation. AT equals half times B times H, as it's given 150, B equals 260, so AT equals half times 260 times 150 equals 130 times 150. On a calculator that gives you 19,500 millimeters square. You can do a quick check by hand if you forgot on your calculator or you can't get one. There's 100 times 150 plus 30 times 150, and 30 times 150 is 30 times 100 plus 30 times 50. So it's 15,000, 3,000, 1,500, so it's 19,500. So using the diagram as provided, which was this one, you got volume. Using the diagram as provided, there are 10 steps. So and the width of the stair is 1,000 millimeters wide. It's 1 meter wide. So the volume of one step is 19,500 times 1,000 millimeters cubed, and divided by 1,000 to the power of 3 meters cubed. So it's 19.5. So that gives you 0.0195 meters cubed per step. The volume of one step. The volume of one step is easy because I've just written it out there again. Area times the width, which is 19,500 times 1,000, which is 19,500,000 millimeters cubed. Width of the stairs is given as 1,000 millimeters. So the volume of one step is 0.0195. Look at the diagram, 10 steps, volume of 10 steps. So now we've got the volume of one step, so we need the volume of 10 steps. Or you could do it, you could now find out how many steps there are per length, but this is easier in my opinion. I just did it like this. So there are 10 steps, the volume of 10 steps is 0.0195, which is the volume of one step times 10, equals 0.195 meters cubed. The unit weight of concrete is 24. The weight of 10 steps is therefore 4.68 kilonewtons. So it's just show you how I got that. 0.195 times 24, 4.68. So the total weight of the steps is 4.68. So now we need to find out the unit loading for the design. We have the geometry of the stair as given, copied above, approximate area by inspection. So it's supposed to span 3,000 horizontally and rise 1,500. So in theory, alpha should be 22.5 because it's if it was 45 degrees, it'd be 3,000 up and 3,000 along. So it's clearly that 45. But let's just check that to make sure. Tan alpha here equals 1,500 over 3,000 equals 0.5. Alpha equals arc tan 0.5 is 26.565. So my estimate was broadly correct, but worth checking. Right, hold on, this is going to be stopping again.